recording. And yeah, feel free to interrupt anytime to ask questions, etc. So let me share my screen. Okay, so yeah, thanks for coming to this presentation. And basically in this presentation, I tried to find the current like state of the art with like, oh yeah, that record. The current state of the art with like reasoning with LLMs. And I mainly got the papers from like 2 GitHub repositories that I put in the Discord chat. But yeah, it was pretty interesting. So the main agenda that I have is firstly we will cover like what is reasoning.
Recording in progress.
And then we will kind of go over something called the emergent abilities with LLMs, which is a bit interesting. And then we will go over like advanced prompting techniques. And by this I mean mainly like graph of thought, which is a pretty new prompting technique. And next we'll go over like some analysis of like LLM reasoning. And by this we mean like, oh yeah, any questions in chat? Yeah, I'm recording it on OBS and I think somebody else is recording it too. We'll kind of go over like analysis of like what does like the LLM expect of the user in the prompts when like you are prompting it. And finally, we will go over like some promising approaches, like some symbolic stuff or self-play and stuff. Okay, so first of all, what is actually reasoning? And for this, I mainly kind of like learned this in this paper called Natural Language Reasoning, a survey. And they had an observation that for philosophy, reasoning is like inferring like new ideas from like set of like assertions or like set of like stuff we know that are true. And we won't call like sensation, perception, feeling reasoning. Like for example, for NLP, we'll say like understanding something or like slow thinking is reasoning, but we won't call like memorization, looking up or like matching information stuff reasoning. This is kind of like this is based on like bunch of papers I got from GitHub repositories, and I have like a write-up. I kind of like compiled a list of them in this link here, this Medium post. So actually, let me put it in the chat, so you can follow along there if you want. Okay, so kind of like the conclusion from this is basically for reasoning we can't just have like RAG or something to just retrieve information and call it reasoning. We have to actually do some kind of like processing on it. And kind of like in a bit more formal way, basically the authors thought of this as like, we have like bunch of like statements or like propositions and stuff here. And a reasoning is given from these premises and stuff. We kind of reach like bunch of like intermediate conclusions using steps called inference to finally reach the final conclusion. So that is what the authors defined as reasoning. So like some examples are, oh yeah, questions? Awesome, yeah. Voice works perfectly, awesome. At the bottom, make sure to configure your audio output source.
Hey, are there any links for the paper that you can share with us?
Yeah, sure. It's basically I kind of compiled a bunch of them in here in this Medium post. So, and basically I mainly got the papers from these repositories here, but I didn't cover like every single paper in here because they were a bit too much. But you can kind of like click on the links. You can just follow along with the presentation here and just click on the links as you go. yeah, sorry for the hassle, but kind of like there wasn't like one survey paper that covered everything, so that's the how it works. And yeah, yeah, that'll work. Okay, so for example, it's kind of like for, let's say we have premises that all humans will die and Aristotle is human. Then death is waiting for every human. It's not reasoning because it's like the exact same thing as this premise. But if we combine both of them and said Aristotle will die one day, then this is reasoning because it actually kind of does some processing to come up with like a new conclusion. So we kind of like talked about inference here, but like what actually is inference? So the paper mainly talked about two ways, and the first way is deduction. And honestly, like for most of the reasoning papers out there, the reasoning done is all pretty much deduction. And basically, it's like using like a fact and a rule to like come up with a conclusion. So like for example, Aristotle is humans and all humans will die, then Aristotle will die. That's like a deduction thing. Now like the feasible inference is like kind of like trying to find out the rule from like bunch of like phenomenon happening. A bit like physics, like where you can kind of like see the ball bouncing a lot, so you come up with gravity or something like that. Or like in this example, given that Aristotle is human and Aristotle died, the most likely explanation is that all humans will die. So kind of like this kind of like inference is very like important, but there is not that much research for LLM reasoning on it, and it can be used for like law, like understanding like law and stuff too. And yeah, kind of like a bit of like comparisons between the two. Deductive inference is always true, like it's always like valid or invalid or something. But for defeasible inference, we just come up with the most probable explanation. So it's only always like probably true, and like you can only like strengthen or weaken your argument. You can't kind of like definitively say that something is true. So yeah, overall, that's like the basic overview of reasoning. But kind of like how are LLMs like good with reasoning? So first of all, let's look over like the requirements of natural language reasoning that was raised in the paper. So first of all, we want to gather a bunch of knowledge, gather all the premises that we need. This we won't cover as much, but it's kind of like mainly the idea is like doing like RAG stuff. And second of all, it's like knowledge understanding where like of like which premises are important. And finally, like the inferences that we talked about of like getting like intermediate conclusions to reach the final conclusion. Questions? The difference between first order logic axioms. I guess like kind of like my understanding is that so logic axioms are like the premises, and like kind of first order logic kind of like each step is like an inference, and like the yeah, and like after a bunch of those inferences we come up with a conclusion. So like that's like that's like that's like reasoning in my understanding, or at least that's deductive reasoning. So yeah.
Yes, so what I meant is that basically you were comparing like the deduction and the reasoning. That deduction would be more like first order logic because that's something we can, I mean, there's not enough software to check if rules of first order logic apply and how they apply, where the inference is more, is not expressed yet, at least in the knowledge, as being first order logic.
You're talking about the defeasible inference stuff? Yeah.
Yes.
Yeah, kind of like, I don't think it's possible to solve. I know that for defeasible inference, it's always like NP hard and stuff, right? So like, I don't think it's like, like since everything is like always like probably true. You can't
Yeah.
conclusively say anything, so everything
Yeah.
becomes like so computationally hard, kind of. Yeah,
It's implied. I mean, not implied, but as you said, supposingly true.
exactly. Yeah, yeah, yeah. So yeah, yeah, definitely. Kind of like I'm more interested in these kind of reasoning personally, but I don't think we are quite there yet now.
No, no, no,
Yeah.
definitely not. And just to for the slide you were on,
This one?
the knowledge, yeah, the knowledge acquisition. Would you say that ontologies are that kind of knowledge acquisition?
Yeah, yeah, I think so. Like it just makes it easier to like acquire not like the specific like metadata of a certain thing, right? So like
Yeah,
yeah, I think that's exactly I think ontologies make it easier to do knowledge acquisitions. Yeah,
sure, sure. Or to express it in at least a way that is understandable by graphs and so.
yeah, yeah,
So,
yeah,
yeah. Thank you.
definitely.
Sorry for disturbing.
No, 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 no. Feel free for anyone to interrupt anytime to ask questions. Okay, so the advantage of LLMs here is that the LLMs already have an understanding of natural language, and also it has understanding of like common sense reasoning without like mentioning them explicitly. Which like if you looked at like papers like quite before now, it's kind of like pretty much it's what a lot of researchers struggle to do. And thirdly, there's like in context learning, which means that you can kind of like give some demonstrations of how to do something to the LLM, and the LLM can learn how to do it, kind of. So, kind of like the fourth stuff that the authors mentioned, which is quite linked to the first thing, is that LLMs have something called emergent abilities, which is a pretty interesting and also a bit controversial topic. So yeah, kind of like I think I'll cover it here. So kind of like first of all, like what exactly is an emergent ability? So the authors define it as like an ability is emergent if like it's not present in like smaller parameter models, but like it somehow suddenly appears at like a certain parameter count for larger models, and they can't be predicted. Like you can't say like train GPT-2 and say like, oh, if we just scale it like 2 times, this will happen. Like it's a bit of a unpredictable phenomenon. So yeah, kind of what exactly do the authors mean by this? And kind of like some examples are like, for example, modular arithmetic. All these are kind of like from a data, all these top ones are from a data set called Big Bench. But like, let's say for modular arithmetic or like word unscrambling, this is the x-axis is the parameter count of the model, and the y-axis is the accuracy. So you notice that until like parameter count of around 10 to 22 or something, basically for at least for modular arithmetic, the models do not like they are not ever like very good at modular arithmetic at all. But for some reason, after reaching a certain parameter count, we see like an exponential rise in capability, which and this kind of like unpredictable rise in capability, these are called emergent abilities. And yeah, kind of like some of the databases used is like something called Big Bench, which is basically like 200 types of crowdsourced benchmarks, or Truthful QA, which is like questions that GPT-3 failed in, or like MMLU, which yeah, is probably one of the most famous one, which kind of like includes like 57 tests with like topics including math, history, law. I guess a bit like common sense reasoning stuff. So kind of like on like a basic level, this makes sense. But like, what about with like better prompts? Like, let's say, what about with like the famous chain of thought? And yeah, kind of like the chain of thought is honestly a pretty like simple technique where basically you have the question and this is like a demonstration question and answer. So you have the question and you say the answer is 11. For chain of thought, we just add like reasoning steps of say Roger started with 5 balls, 2 cans of 3 tennis balls, each is 6 tennis balls, and all these kind of steps. Basically, by including these kind of like steps in the middle, it kind of drastically improves the capabilities of the model for some reason. So this is called the chain of thought. And another like technique is basically the idea of this technique is not that much like prompting technique, but more like fine tuning. So we kind of like have the input and the output, I think, and you just kind of like fine tune it on these tasks with this certain format. And this is called like instruction tuning. And then given this new input, it should like output the right thing. And another thing that this paper tested was something called scratchpad, which is let's say for this addition task, it kind of like decomposes it and like and forces the in the in context learning part, it kind of adds this scratch like HTML thing to oh yeah I have the recording, so I will upload to YouTube. But basically this scratch thing to kind of like record the carry digits so that these kind of arithmetic tasks will be easier, basically. Now for the fourth prompting technique, it becomes a bit more technical, but basically this was a yeah sorry this is a bit of a like a bit of like a off the main topic, but basically the fourth technique that the authors use came from this paper called Language Models Mostly Know What They Know. And the main idea is that can we get like the confidence of the LLM's answer along with the answer? And it mainly and basically the prompting techniques all came from making sure that the confidence of the LLM sorry, let me first explain this paper. So first of all, let me explain what calibration means. So there was like a paper before this called Teaching Models to Express Their Uncertainty in Words. And after many like trained like GPT-3 on like arithmetic tasks so that the accuracy of their prediction actually aligns with their confidence. So let's say we have like a LLM add like 2 numbers, which is like 16 plus 13. The confidence, we ask the LLM verbally how confident you are, and it can say like, let's say 95%. Then what we do is we ask GPT-3 that question like 100 times, and we want it to be correct 95 times, and 5 times it should fail. So basically that's like what this calibration means. We basically want the confidence and accuracy to match up, kind of. And basically these authors in this previous paper trained the model so that this value becomes as low as possible, that the accuracy kind of like aligns with the confidence. Yeah, does that make sense? Okay. Asama-san. Okay, so basically now kind of like the idea of this new paper is, can we have like prompting techniques and stuff so that we can get like a very low value for this without training? And first
I see that the question is like being asked again. I asked the same question. If it relies to perplexity, so the metric, what you're now explaining here, that was one thing. So that the confidence you're expressing here, if that is like bound to the metric known perplexity, I don't know if that rings a
Uh,
bell.
I think for perplexity, it's based on like log probabilities and stuff, right? So kind of
Yeah, so
like,
the confidence of the next token, basically. So that's why I'm referring to that as a reference to that. So it
yeah,
is in the log, it is between the tokens, but that's for me an accurate way of measuring the confidence of the model in what it said, right? If you take an average of the perplexity for each token, you get basically like a sentiment of a confidence that the model had in his own answer. But that's something you calculate from the outside. How reliable is it when you ask the model himself? Like, how confident are you with this?
and
Um,
that's a great question, and actually what this paper teaching models to express their uncertainty in words actually tried comparing against. Kind of like one
okay.
critique I have of that method is like, let's say for like a single token, that definitely works, but let's say if it's like a whole series of like, let's say if it's like this entire sentence, right?
Yeah, yeah.
Then there's like multiple different ways, combinations of tokens to represent this exact same sentence. So essentially you have to kind of like look over like all combinations of tokens and all combinations of log probes and compute all of them in order to like finally come up with like come up with,
And that is something I
yeah.
could do, or I feel I could do with the perplexity metric. But that's not something, I mean, LLMs prove every day that they can't do math, they can do a lot of calculation steps. So what is a confidence score coming out of the LLM itself worth? I mean, if he hallucinates about what he's saying, he will hallucinate about the fact that, yeah, I'm 95% confident of what I just said.
Well, yeah,
So
yeah, theoretically that's true, but for some reason, kind of like that the authors actually compared like the log probes with the asking the LLM verbally on like how confident it is. And for
okay.
some reason, like asking the LLM how confident it is actually does outperform the log probe approaches. Yeah, that was like one finding in the paper. And yeah, technically it's true. Like if it kind of completely hallucinates, then I think you're exactly right. It can be it can hallucinate, but this is like a slightly better approach than
Okay,
log probe.
and
Yeah.
that paper is mentioned on your blog post somewhere?
Uh, yeah.
Oh,
I think the link to this paper is mentioned, but I can honestly
yeah,
I
well, I
can
will.
post all the links in the GitHub maybe. Yeah.
Perfect,
Yeah.
perfect. Sorry for again.
No worries, no worries. Yeah, any more questions in chat? So, how did I ever the result ask the model itself? Yeah, it's honestly it's kind of surprisingly pretty reliable, and kind of like in future techniques that I will mention, like tree of thoughts, like wait, ask the LLM like how confident it is at each node. It's actually the reason that works where you can ask the LLM how confident it is because I think of this paper. How do we know the accuracy is not? Oh yeah, it's I think the same question. So that they,
Yeah, that's why I asked it live, because
uh,
it was coming back from someone else. So yeah,
gotcha. Thank you. And so that's why they kept it to arithmetic. Yeah, I'm not sure why, but I think it was only arithmetic questions. But kind of like in this paper by Anthropic, they kind of like go over more of the they go over more of the more different tasks like true and false and stuff. The yeah. I think this yeah I think this works. Okay, so now so basically now let's go over some of the prompting techniques. So kind of like one thing that the authors noticed, so this is an example of a bad technique, is that replacing an option, let's say in a multiple choice question, with none of the above actually harms the performance of the model. So you should always actually have like a good, you should always actually have like an option there. And yeah, kind of like basically for accuracy and stuff, as you see, like with increasing parameters, overall, like it's always better to have an option rather than none of the above like this. And this is the how we measure the calibration. And this confidence, this probability stuff is the probability we ask the model, like how confident you are. And this frequency is the frequency it was correct, like in terms of like probability. So basically, if it's an exact straight line, this loss is zero, so we can say it's fully calibrated. When we add in now the above, an option called now the above, what happens is that it's kind of like, so this is the confidence. It has like lower confidence for like how accurate it is. So basically kind of like the confidence kind of decreases a lot when we add in like now the above. Well, without it, it's kind of like pretty much like a well calibrated model, basically like this. So another kind of like thing that they found was that for like true and false questions. So this is what the emergent ability papers use for like benchmarking how good it is. But when you kind of like ask it in the form of this, or like who is the first president, proposed answer George Washington, is the proposed answer true or false, like this. This kind of like this apparently prompt format is the best. And one thing that I wanted to highlight here is that here we ask the model whether A or B is correct, basically. But if we instead say true or false, if we try to make the model instead say true or false, or like yes or no, one thing I noticed is that for LLMs, they really love saying like the word yes or like true or like all those positive stuff, at least for low parameter models. So I think like having it instead say A and B and stuff, that's kind of like help like the log probe and stuff a bunch. So yeah, kind of like this is a final prompt, kind of like partial prompting technique that the authors raised, which was basically kind of like when we do like reinforcement learning with human feedback, the authors claim that it tends to like collapse the language model predictions to maximize the reward. So what this means, I think, is like it kind of like just tries to be overconfident all the time, like always kind of like saying stuff that it doesn't know with like full confidence to like maximize the reward by like humans. But apparently, I have no idea why, but increasing the temperature of the prompting to 2.5, the default is like 1.0, actually kind of fixes this. So like more random output from the model seems to fix this distortion from like reinforcement learning with human feedback. Okay, so now that's done. Let's go back to the emergent ability paper. So one thing that we found is that curiously, for low parameter count, all these techniques underperform a bit, like that. But at a certain parameter count, all these techniques kind of like show a bit of emergent ability like this, like an unpredictable exponential rising capability like this. So yeah, kind of like there seems to actually be something to like emergent abilities, or like some unpredictable kind of like increasing capability at a certain parameter count. Yeah. If you add now the about question, yeah. Honestly, I think this is a. I think one thing I found with a lot of LLM reasoning is that a lot of it might just be like something that humans do too. If it has an option escape or don't know, instead of having it, there was an alternative. I think. Oh yeah, I forgot what the base model is here, but I think it does match it. Yeah, that will make a lot of sense. So
Yeah, so if you ask him to choose between three options, it might be like, I don't should be this one. But if you give it an escape manner, so a manner to say, oh, I don't know, or none of the above, all of a sudden it feels much more confident in choosing one of the options.
True, true. That
Again,
that makes sense.
do not know why, but in the other sense, it often like I need to make an answer. I need to make up an answer in between those three, and it would be like these three. So let's say he would uh, uh, distribute that in 30% of confidence for each one. But if you give it also an option of like, oh, it's none of those, then all of a sudden the probability, or I mean, say the confidence, like starts to toggle
Yeah,
because he get
yeah.
that option.
I guess you mean like right around here, right?
Yes.
Yeah. Okay, that makes sense. But honestly, kind of like I'm not sure why they. It kind of seems like they kind of cut off right here and didn't like plot all the way. But yeah, maybe you're right. Like maybe right here it starts to be on the line or something like that. Yeah, yeah, yeah. I should read the paper again to come back to it. But yeah, at least for though, at least here it seems to be like lower confidence. Yeah, you can definitely see students reading semi effect. Yeah, 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 definitely. Okay, then now kind of like this is kind of like pretty interesting, and kind of like the authors kind of like came up with some ideas on why this happens. So first of all, kind of like the idea is like for computation that takes like L number of steps, maybe like let's say for example in chain of thought, they might want at least like a model depth of at least or OL. So like yeah, so maybe for some reason for like maybe we need to like have like a certain size of a model in order to actually do these tasks in the first place, or at least reason about these tasks. And I think the second option kind of resonates me with a bit more, but I think like with larger parameter count, basically it has more memorization of the world knowledge, so it has more like common sense reasoning. The third kind of like idea that the authors kind of threw out there was that basically these kind of like these kind of accuracies, there's no like partial credit to them. So maybe like maybe it was the case that for like large models they were able to get the answer, so we see that drastic rise. But maybe for like smaller models they almost got the question right, but we just set them to zero every single time. But kind of like yeah, but the issue is that the intermediate steps for like the smaller models were pretty random according to the authors, so they said that this wasn't necessarily a case. And I think I saw a question there. Because we are giving it valuable extra information. The right answer is one of the listed options. Real option I don't know helps most of the time because we don't know the answers beforehand, so it helps. I guess yeah, that's true. Anyone that's several. I'm recording it right now, so yeah. Oh, interesting. That sounds pretty cool. Okay, so now we kind of like went over the emergent abilities, but kind of like this was with the idea of chain of thoughts and these kind of like pretty old prompting techniques. So do we like actually get like better output with like more advanced prompting techniques? So yeah, let's now go over the more advanced ones. So yeah, first of all, the classic one by Google is the tree of thought paper. And the basic idea is we basically kind of like have it output multiple kind of like versions of the answer, and we kind of keep expanding like these intermediate outputs more based on like how confident the LLM is for like each of these prompts. So it's a bit like this where like if it's like we ask the LLM like if it looks good, like if it says sure, it must be like pretty confident. If it says impossible, then this must be like a very bad reasoning path, so it will prune it. And if it says maybe maybe put it down in the queue for like lower priority. So it's a bit like A star search where it kind of like looks at the about not fully A star search, maybe like a heuristic search where like it kind of like looks at the node with like the highest confidence every time to kind of keep expanding. So yeah, kind of like one thing I thought of was that I think this is very much inspired by the calibration paper because it does ask the LLM how confident it is in the answer, and that is kind of used as a benchmark to see how to expand, which they shouldn't have known is possible unless it's kind of like a known fact that that's better. And any questions? If anyone, yeah. So now kind of like that was tree of thought, which is honestly pretty old right now too, I guess. But another new paper that comes out, actually there's quite a bit of like these papers, but it's the idea of like graph of thoughts. And the first paper I want to talk about here is Beyond Chain of Thought, Effective Graph of Thought Reasoning in Language Models. And
sorry to interrupt, but there is a huge echo or loopback. I don't know if it's only me.
Maybe interesting. Actually, maybe maybe when somebody is speaking, maybe just unmute for a bit, then maybe it'll go away. Like I think everyone's muted right now, so can everybody Can everybody hear the echo? Okay, I guess now it's fine. Then okay, then sounds good.
I'll reload mine.
Sounds good. Yeah. Yeah, I don't think it's Discord because I'm out of the call right now. So, okay. Then, yeah. So basically the idea of this paper was that in chain of thought, we kind of like have this linear form of thinking. So let's say from X, we can say Y, and from that we can say Z. But like in reality, I think our like thoughts are a bit more complicated. Like we can kind of like have like loops where like we can kind of keep looping between X and Y for like more reasoning or something. Or like maybe once we get to Z, we loop back to Y and to X and so on. Like basically our thoughts must be like a bit more like graph-like, where like each node can connect to any other node in the course of like coming up with a conclusion. So what this paper did was kind of like this diagram makes it isn't super clear, but basically kind of like given like from text features, we kind of extract like rush. Actually, yeah, this diagram I like a bit more. Basically, given the input text, it constructs a graph like this, and then it also has a vision encoder, which I think is cool, but like not relevant to reasoning currently. But we have the input text, we encode it in the text encoder. Given this input text, basically what they do is they kind of like do something like make a knowledge graph by like getting a bunch of triplets of like kind of connecting like facts, like United States is a country or something. And then we make this kind of like something called a thought graph. And then we just encode it in like a graph neural network and stuff. And then do like cross attention like this. Kind of, I think I covered like something similar to this in the understanding like graph machine learning in LLM stuff, but this is like very similar to one of the papers I talked about there, which is called like Gitmo, where like they combine like bunch of like graph neural network, like text encoder, image encoder, and all that using like cross attention like this. So yeah, I recommend like checking out that paper if you are interested. But I think it was called Gitmo. But overall it's a very simple idea. It's kind of like we have a graph encoder and we have a text encoder, and we just fuse it all together to to the LLM to kind of give information to LLM to output like text. But yeah, there is a bit of an issue that I personally had with this, which was it kind of like it outperforms like chain of thought, but basically the only part that's the graph in here is converting from the input text to this graph and then operating on that. And it doesn't necessarily make the thoughts like a graph, you know? Like it just kind of like plugs in like a graph, turns the input text into a graph and plugs it in, which I guess improves like understanding of the input text, but it doesn't necessarily make the thoughts a graph. Yeah. Which, and this was like also the conclusion that the GitHub repository owner had for this paper. So a bit more, in my opinion, a promising paper was this one, boosting logical reasoning in large language models through a new framework, the graph of thought. So yeah, as I said, there's like a bunch of graph of thought papers. I think there's at least like 4 now. And the idea came from the Goldbach's conjecture. So the idea is like every natural number, the Goldbach conjecture is that every natural number greater than 2 is a sum of 2 prime numbers. So like 4, 6, 8, for all of these, we can kind of like sum like 2 prime numbers, like 3 and 5 to get them. And the idea that the thought that the authors had was like for like mathematicians, they did not kind of like go through every single possible way of solving a problem to kind of like reason to go to a conclusion, like a tree of thought. And instead kind of like they find like promising avenues of research, and then they try to go through like those routes, and also they kind of like also like backtrack from the conclusion to try to kind of like do like proof by contradiction kind of stuff. So basically kind of like it's pretty impossible to say solve like a very hard math kind of like proof using like tree of thoughts way. You have to kind of like have this kind of graphical kind of thinking in order to solve. Oh yeah, sorry. Every even natural number greater than 2. Yeah, cause yeah. But yeah, you can't kind of like use the way of thinking of tree of thoughts to come to like solve like a very hard mathematical proof, because it just kind of like keeps expanding into like extremely large search spaces, and it's pretty infeasible. But if you use like graph of thoughts way of thinking of like, let's say, given this conclusion, let's see contradiction and stuff like that, and like backtracking and stuff like that, the idea is like you can eventually like come up with an answer in a more like human way. And how like this kind of works is I won't kind of go into too much detail in the technique because it's honestly pretty complicated, and I don't think I fully get it too. But basically we have like the goal, which is the solve function, and we have the initial like input or initial like problem, and then we kind of like have these nodes to kind of like we kind of expand the solve function to, oh, we might use the formula method or prime factorization or substitution method, and then we kind of like go through like pretty like a graphical kind of like reasoning kind of way of of like reaching a conclusion, but it's kind of like sequentially adding nodes to like random nodes, I think. Yeah. Yes. Sorry, I don't fully understand the implementation of the paper. Kind of like I went over the pseudocode in the blog in the write up a bit, so feel free to check it out if you want. But overall, there's like certain types of nodes, and then you expand them, and also like when you expand them, there's like inspectors to completely make sure that it's like a valid expansion. And basically by that it means like asking the LLM n times whether it thinks it's a valid expansion, and then it keeps growing. One critique that GitHub also had of this paper was that there's no way for once a thought to be made to delete the thought. So the idea is like if you have like one bad thought, it might actually ruin the entire idea of this paper. So basically the solution the authors had was just to be very careful, which is a bit flawed. But overall, kind of like I think this kind of approach is very cool and interesting. So yeah, kind of like for evaluation. So n is like the number of inspectors. So if there's no inspectors, the accuracy for like solving polynomial expansion is pretty bad, although a bit way better than like tree of thought or chain of thoughts. But with like 5 inspectors, it actually beats tree of thoughts with a calculator. And then for like graph of thoughts with a calculator, it's like just better than all these other approaches. For like prompting techniques of like solving these kinds of problems, I noticed that this paper consistently has the highest evaluation in terms of like solving polynomial equations and stuff, at least as far as I can find. Okay, so yeah, I don't think there's any questions. So I think I'll go on to like analysis of LLM reasoning. Okay, so kind of like this is a section where we kind of like go through like what LLMs expect of us as prompters to kind of like come up with like a good solution. So in this paper called Towards Understanding Chain of Thought Prompting and Empirical Study on What Matters, the authors found a pretty funny kind of like thing where that for chain of thought, usually you think that having like very good like descriptions on like what kind of like reasoning process you should go through to come to the final conclusion, that kind of like having good explanation of how to get the solution is important. But what the authors found was that even if you have like pretty much extremely wrong reasoning steps in the middle, like right here on neurosymbolic. I'm not sure about neurosymbolic, but I want to talk about like a bit like symbolic reasoning with AI. But yeah, not sure about neurosymbolic stuff. But yeah, anyway, kind of like even if you have like absolute bogus kind of like explanations on how to reach a conclusion like this, it seems to still be like pretty performant. Like, of course, it drops in performance a bit, but it's not like by a significant amount. So there's something like a bit weird going on in the chain of thought. Like it seems to just like want like a explanation to happen, like some kind of explanation to happen, while like the accuracy of the explanation isn't too important. So another thing that yeah. Okay, another kind of like different paper that was interesting was large language models can be easily distracted by relevant context. So what the authors did was basically they had like a grade school math like 8,000 benchmark, and basically they added like bunch of like irrelevant details in the prompt, and basically they evaluated the models on that. And what the authors found was that when you do this, it gives rise to like a drastic like drop in performance for the LLMs, even if like this part is like completely irrelevant. Hearing an echo because you are in Discord and Zoom. Oh, okay, yeah, maybe you should get out of Discord and maybe it'll fix it. Yeah. So yeah, so basically kind of like Oh, I forgot about that was a pink elephant paper, yeah, right. I haven't read it yet, but I heard it was good. So
But the idea is if you even if you tell on the model like elephants are not blue or whatever and so on, and then you ask him what are typically colors of elephants, it all of a sudden will answer like, oh, elephants are not blue, but they can be pink, red, and whatever. And so it's just about the fact that you tell him don't think about this, and so you give information in the context, and by actually telling him it's not this or it's not that, you influence him to think about these because now the tokens are part of your prompt and their probability raises. If that makes sense.
yeah, yeah, it does. Kind of like one thing that I thought was interesting about LLMs is that I think it might be part of like the instruction tuning part, but they're kind of made to be extremely reactive to the prompt or like to honor like what the prompter says as much as possible. And I think that kind of like makes it so that when there's kind of some adversarial prompting like that, it kind of like makes it completely underperform for some reason. So honestly, I think it's a data issue rather than the LLM architecture issue. But can I get? Oh yeah, the title is this: large language models can be easily destructive by relevant context. Oh, oops, the or yeah. Uh, I think that worked. Yeah. So so, but kind of like one thing the authors found was that if you break the problem into sub-problems and use self-consistency, which is like asking the model a bunch of times and like checking which one has like the highest vote, which I don't think works for like pink elephant problem, but like let's say for multiple choice problem it works. And also like instructing it to ignore the irrelevant details. If you do like all three of those, LLMs become robust to them quite a bit. But like, yeah, one thing that I thought of was like LLMs kind of expect a user to be a bit like a teacher in like it should tell it kind of like how to do the task and like make sure to not distract it as much as possible. Yeah. And but what exactly you teach isn't too important as long as it's kind of like it's pretty clear what to do for the new problem kind of. So so this is the kind of like one of the more interesting papers I think, which is called Language Models Don't Always Say What They Think, Unfaithful Explanation in Chain of Thought. And I think this was by Cohere and Anthropic and stuff. And kind of like one thing that the authors found was that the LLM can kind of like first make up its mind on what the answer is, and then come up with like chain of thought to kind of like supplement that implausible answer in a way. And how they did this was basically kind of like they biased the answer, and this is a so these are called the biasing features by the authors, where they made it so that in context learning example, let's say all the answers are A, so the LLMs will be highly biased to say A, or like let's say for the bias feature B, you can say like I think the answer is A, but I'm curious what you think, like those kind of stuff. So what the authors found was that first of all, like kind of like to make the correct answer for the LLM, it has to first acknowledge the bias it has. That like it should acknowledge that all the answers in the example is A, or like it should acknowledge that the author thought this. But out of like the 426 examples they did, only once did the LLM mention this bias it had. And also like the biasing feature of course made the LLM more prone to output that answer. But for the reasoning it had, it was always not like these kind of these kinds of like it never mentioned like these biases that was inherent in it. It always kind of like came up with a different chain of thought answer to kind of supplement that answer in a way. Yeah, does that make sense? Yeah. So kind of like for some interesting graphs on this. So let's say we have an unbiased context and a biased context, and the biased context is the one like this, like where the answer is always A or the answer is suggested. For chain of thought, which usually should outperform like the normal like prompting every single time. For zero shot, honestly in both times, chain of thought actually kind of drives away from the answer more than like without chain of thought if you're adding like biased context. Like without biased context, chain of thought always outperforms normal prompting. But with biased context or like some like distracting information, chain of thought actually kind of like goes away from the answer. So chain of thought kind of like intensifies like the misunderstanding it has. But like I think like with few shot, which means I think a bit like self-consistency, where like it's kind of like I actually maybe like actually I'm not sure if this is like self-consistency or like multiple examples, but I think like self-consistency, but then it kind of like is able to like beat normal prompting. So it's a bit interesting in that way. Yeah. So honestly, this is kind of like one of the more. This was another paper that I liked, which is by Google DeepMind, which is that large language models cannot self-correct reason yet. So a lot of like interesting papers, like there was like papers like reflection or something, where basically you first have the LLM output like a certain output, and then you evaluate the LLM on say like, okay, do you think this output is correct or not? And then you come up with an answer. And then you have the LLM output a reflection saying like, oh, since I'm low confidence in this answer, what should be a better answer then? And then it does it. And then you update. So the idea is kind of like you can always keep updating by having the LLM critique itself. Basically, the idea of this paper by DeepMind is that this isn't true. You can't actually do this. And the idea that the DeepMind authors had was that if an LLM possesses if it can already like output the correct answer after like critiquing itself, why wouldn't it do it in the first place? And what the authors found was that for like a lot of these papers, like for this one it's called deflection, they found that they kind of like cheated a bit in order to achieve the results, while the DeepMind authors themselves weren't able to like achieve these results. However, like one thing I will say is this is like a result of like for intrinsic evaluation, intrinsic reflection, in that you ask the LLM to evaluate itself and output the correct answer. However, if you use external signals, a bit like here, where you have like environmental reward or something, then it actually works. So if you ask it itself, it won't work. But if you have like outside rewards or something, then it can work. So basically, self-reflection won't work, but like if you include like outside information, then it will work. So yeah, that was a pretty interesting paper, and the reason it was interesting is because there's so many self-reflection papers. Like I did another literature review on a different topic about like agents and stuff, but like especially this reflection paper or like self-correcting paper, it's like referenced pretty much everywhere. So yeah, I think this is a pretty important paper for people to know. Okay, so I think this is like one of the more final papers on LLM reasoning, but the one of the more one of the pretty simple paper that I wanted to mention was that basically for the chain of thought, if you have like longer reasoning, for some reason apparently the accuracy increases like this. so basically you always want to have like very long descriptions on how to reach the answer rather than like a very short description. So the method that the authors used was they just had GPT-4 increase the reasoning steps, and yeah, basically it basically beat having short explanation. So more than like simple is the best. Just have like very long explanations, and apparently that will improve reasoning. But yeah, kind of like one thing that I wanted to say as like for chain of thought is that like teaching the LLM like in depth on like what to do is the most important with like minimum distractions. But like if I don't think it's like very good in like out of distribution stuff where like the teaching isn't too applicable. So basically you have to kind of like already know all the situations the model will be in order to actually have like good prompts. You actually have to design prompts for all the situations for the LLM kind of basically. So it's not like a very scalable approach in my opinion. So basically, yeah, the question now, at least for me, was like, is there like a more promising approach than just like human ingenuity for like good prompt design, like graph of thoughts and stuff like that? And yeah, the first promising approach that I wanted to mention was this paper called Logic LM. And the idea is pretty simple. You first have the problem, like here, and then you basically convert the problem into like symbolic representations for like a logic solver, and then you basically solve it, and then you get the answer. So it's a bit like this. So actually the resolution is pretty low, but you have these inputs, you convert the like premises, rules, facts, and like queries, and then use like Python tools to get the answer like this. So this did like extremely well. Like it kind of outperformed GPT-4 by a bunch predictably. And yeah, here's a list of solvers like Pike, Prover9 and stuff. But yeah, kind of like so this is a pretty interesting approach. But the main issue is that is like fundamentally we have to translate the problem to like a logical formulation, which might not work with like which will probably not work with like defeasible problems like law. So which kind of like yeah, where like everything's up for interpretation kind of. And another thing is that yeah, mapping from like problems to symbolic reasoning by itself is not a trivial problem. Yeah. Oh yeah. Any questions? Oh yeah. Here. So it's like linear programming, deductive reasoning, first order logic, constraint satisfaction, and analytical reason, like that. Yeah, I'll post the slides after the presentation.
Perfect, thanks. That was an interesting slide. I wanted to capture it.
Yeah. No worries. Then, kind of like another idea that people had was like kind of like for this might be good for like problems where the final solution can be gotten from like this symbolic solver, but what about if we want to do like intermediate computations in the reasoning process so that we and kind of like offload that to like a reasoning like expert and then have it kind of offload it to a reasoning expert so that it can kind of like return back the answer so you can kind of keep reasoning. A bit like agents. Like, can we actually do something like that? And one paper by Meta was like this one, like efficient tool use with a chain of thoughts, obstructive reasoning. And the idea was like for like for each problem, you train the LLM to output something like this. So like for this in this 90-minute frame, Mark played 20 minutes on the other another 35 minutes. How long was he on the sideline? And you kind of like use the like symbolic stuff to kind of like to kind of come up with like equations in order to like solve the problem, kind of like that. And basically how the authors did it was like for like given a given an answer explanation, they converted like every single intermediate solution to like symbolic stuff like this, and then they trained the LLM to always like output in this format. So yeah, kind of like one assumption or like that I think this paper had was that for these problems it worked, but it assumed that the reasoning is like unrelated to the result of the tool call. So basically, we don't have like an intermediate reasoning where like given like the result of this was this, so now we can conclude this. Overall, it was like just like a bunch of like algebra basically, like it's just a group of algebra. So the intermediate results are not computed for the next token basically. So that was like one assumption that this paper had. But the main critique I had of both these papers was that basically for both of them, they kind of completely gave up on the LLM for doing reasoning, and instead they tried their best to kind of like offload all the reasoning stuff to outside experts, which is currently pretty valid, I think. But one issue here is that let's say we wanted to make a complicated story, right? Then if we kind of like keep offloading all the logical stuff outside the LLM, can it actually like understand the complicated plots or like intricacies of the story in like order to like, I don't know, in order to say make a new complicated story? And I think it's possible with like maybe proper prompt design, but I don't think like it's a simple thing to do when we kind of just keep offloading like all the reasoning to be outside the LLM. Kind of like another interesting approach that people were thinking was that can't we just have the LLM be a better reasoner? And this kind of like brings us to a pretty old paper called AlphaZero. AlphaZero, I think at least as far as I know, is the first machine learning model that actually kind of like beat logical systems that humans built. Like let's say for chess, AlphaZero pretty much consistently, about at least like 29% of the time, beats like Stockfish, which is like one of the best engines humans have. Or like for Shogi, it pretty much dominates. For Go, for like the black pieces, it's a bit weaker, but pretty consistently, it's always like way stronger than every like logical stuff that humans made. So the natural extension is that for LLMs, can we improve the capabilities of LLMs to like beat human logic solvers? And so far, the answer is we don't know, but one promising approach, I think, is this one. Self-playing adversarial language model, language games, enhance LLM reasoning. Wait a moment. We can get non-trivial gains from things like tool use or prompting techniques, but probably end up having to just throw enough. Interesting. Kind of like I'm not sure if there's like more emergent abilities down the road at like 1 trillion parameters or like more. Like I think that's a bit of an unknown issue. So maybe there's no more emergent abilities because those are like from definition, they are unpredictable. So we want to know if like scale will solve all the issues too. But yeah, anyway, kind of like the idea of this was that basically there's this game called adversarial taboo, where if you're like an attacker, what you want to do is you want to trick the opponent into saying a certain word, which the defender doesn't know. But if you're a defender, you want to kind of like predict what the word that the attacker is trying to make you say. So this is a game called Adversarial Taboo, which you can play between like two like LLMs like this. And the idea is like, let's make these like play against themselves and like keep doing like reinforcement learning stuff to keep like improving like that. And the main interesting finding of this was that if you do this, like if you do this with chess, what the other researchers found, at least in Lion, I remember like if you do this with chess, the LLMs don't actually like improve in like other capabilities. Like it just becomes good at chess. But if you do this with like with this adversarial taboo game, what they found was that it seems like have like increased general reasoning capabilities. Like the base model is this grayish one, and these are like other models, alpaca supervised fine tuning and stuff. But so this purple one is the first epoch of this training. So we see that for like a bunch of these benchmarks like pronoun resolution, logical reasoning, something called AI2 reasoning, and multi-turn dialogue, or something called Big Bench Hard. For all of these, for each epoch, it seems to like continuously improve the capabilities of the models, at least in these benchmarks like this. So on the third epoch, it seems to outperform every other thing, every other like fine-tuning strategy in here in terms of like logical reasoning. So yeah, kind of like the benchmark is here. Like for MMLU, it seemed to drop a bit, but overall, like doing this supervised self-play with like adversarial taboo seems to like keep incrementally improving like every epoch. And yeah, this is like win rates against GPT-4, like for adversarial taboo, and it seems to like beat it 77% of the time. But yeah, kind of like one thing that you might be asking is like, okay, so it reached like epoch 3. How do we know that this keeps improving? And honestly, we don't. And the reason they only stopped at epoch 3 is because they had compute limitations. But honestly, like this is like one of my favorite papers that we covered so far, because it seems to like actually, I think it has like more promise than like the other. I think it has more promise in terms of like the capabilities of say AlphaZero. But one thing we do not know is how much this improvement is dependent on this game called Adversarial Taboo. Like let's say for like other games, we might not actually get these gains because at least for Adversarial Taboo, the agents must kind of like think about how to the connections with every other token to every other token, because like it has to actually know like how to convince the other player to say this certain word, which I think is a pretty interesting dynamic, at least in language games. Yeah. But yeah. Overall, the conclusion is that kind of like there's not that much. Like I only could find like one paper that used like a graph neural network, which I thought will be pretty much over dominant here, so I was a bit surprised. But yeah, there wasn't much graph neural network papers, which I thought was interesting. And channel thought can be good, but it can easily be distracted, and you have to like teach it good steps and like extensively. And at least in like one like sports benchmark, I think it outperformed humans. For like graph of thoughts with backtracking and self-play, and tool use, I think, is a promising direction. So I'm kind of curious if you can kind of combine them or do like a very smart self-play strategy for some game. And finally, I couldn't find many. I think I found a few, but not that many like defeasible logic papers. But yeah, overall, yeah, that's it, I think. Yeah, I guess it might converge some point, but honestly, like I don't know. I think like for reinforcement learning and self-play, it was like the one thing that one machine learning technique that people found that were actually outperforming like human like logic systems and stuff. I don't know. I think there's a potential for like some AI agents to outperform human logic sometime. Yeah. And I'm not sure if
On the
self
path to
yeah.
AGI.
Yeah.
On the path to AGI, let's say.
Yeah, maybe just training on adversarial games forever it's the AGI. I don't know. But
Anyway, just great talk. Thank you for sharing all this. Waiting for the slides.
I think thank you. Honestly, like everything's in the write-up too if you want. But yeah,
Okay,
I'll
perfect.
upload the
bookmark that.
slides. Yeah. Yeah.
I wanted to ask your thought on this. So a few days ago, right, I came across a paper that said that some guys tried so like how the regular pre-training task is to predict the next token, but some they use the language model to sort of change that original data into like an instruction format, question and answer. And they found I will share the paper on the Discord, and they found that the model ultimately after fine-tuning performed much better. According to them, they said they were able to get a Llama 8B to perform as well as a 70B, for example. So just sort of adding that to everything you just discussed, like, do you think it would be sort of beneficial, like rather than just arranging it as an instruction format, to then even go further and sort of have like a chain of thoughts format and then pre-train on that?
That's a very good question. Honestly, kind of like I'm pretty surprised by just that original paper you mentioned because my understanding of pre-training is like getting like the general knowledge of the data, and like for supervised fine-tuning or like at least the instruct dataset format, I was thinking like it was mainly to align to the chat format. So I'm surprised that it actually like performs better with the combination of the two because I thought a lot of knowledge will be lost there. But yeah, kind of like for chain of thought and yeah, maybe like kind of like one similar paper to that idea, although like not completely, is like this efficient tool use with chain of thought abstraction reasoning, which actually does the chain of thought with this symbolic stuff in like I think the supervised fine tuning stage to improve reasoning. So I think yeah, this will actually do perform better, but I'm kind of curious like what is lost along the way, like for example for this it does like remove the ability of the LLM to do, I think, do arithmetic by itself. Like it completely offloads it to the outside. So yeah, honestly, the answer to that is I don't know. I think we need to evaluate it, but yeah, it's definitely an interesting research direction, and I'm looking forward to that paper you mentioned.
Thank you so much.
Yeah, thanks for that. Sorry. And I just want to say thank you, and thank you for the presentation. It's been
No
great.
worries. Thank you for coming, and sorry for the tech difficulties in the beginning.
Thank you for the presentation. Do you you mentioned the game? Is it Advanced Tableau or Advanced? Yeah.
Sorry, it's Adversarial Taboo. Yeah, it's I think it's a pretty famous game, although I never heard about it before this paper. Yeah, but it seems pretty fun to play. Yeah.
Thank you.
Using the solvers approach, do you think that it's worth, like, on known problems, or I mean, well, of which apparently an LLM cannot solve it right now? to use solvers to basically generate a synthetic data set on which we can train it to learn it about the reasoning rather than really memorizing, right?
Yeah, yeah.
There could be an emerging property coming out of that by using the solvers to basically generate synthetic data, then fine-tune the data set, fine-tune the model, sorry, on those to then obtain the reasoning natively from the LLM instead of using an external solver.
Interesting. Kind of like I don't remember seeing like research like that. Although I'm pretty sure there is some research like that, but kind of like one critique I have of like having the solvers do like the intermediate steps and like maybe just training on that is that the LLM kind of expects like a natural language as as like the as like the inputs, and usually like for solver intermediate steps, as far as I know, I don't think they're like I don't think they're natural language per se. Like there was a paper called Agent Frame, which let's say for agents, it tried to like fine tune the LLM to be to output like better code for like agents and stuff. And in order to achieve that, they had to like make the agent output more like natural language friendly. So I think like if you're adding an intermediate step in there to convert the like intermediate steps to be like natural language like thing.
The idea,
Yeah.
yeah, not the output of the solver itself, but intermediate steps of the solver that would be expressed in natural language, but using the power of a solver to basically produce a data set of reasoning steps and explaining them to the LLM. Of course, not just the inputs and the end result, but the solving path between and explained in natural language, of course.
Yeah, I think that's promising. Kind of like I guess the only issue I see with it is like unlike self-play and stuff, you can't kind of guarantee. I don't know, kind of like can you kind of like always say like like always synthetically create like harder problems for the LLM to keep solving and stuff. But uh, yeah, I guess like the main hardship there is coming up with like good problems for the LLM to for that data set, basically, I think.
Okay. Well, I think the ARC prize, I don't know if you heard about it recently.
The Kaggle competition one?
Yeah, the RSE prize. I mean, that sounds like a good data set for those kind of reasoning steps.
Interesting. Honestly, kind of like I don't know too much about the ARC dataset. I just know that LLMs have a hard time with it, but
yeah.
And
it's all about reasoning and not about prior knowledge. So it is not. These problems are not memorizable. These go really about reasoning. The steps are very easy, and even a child of 5 or 10 can solve those. But LLMs have more than a hard time to fix it. Any of them.
Interesting. Can they always be like synthetically easily created, like those programs?
Yeah. They are basically a grid of numbers that represent colors, and then some of the puzzles, if I can call them like that, is just like rotate the grid or delete, erode some elements, replace a color by another one, and things you visually as a human get without even a lot of text explanation, right? Just you look at the two grids, the input and output. You got a few shops, by the way, where you can learn from, and then you're given a new input grid, and the LLM should produce the output grid. But even with few shots in the context and those kind of things, none of the LLMs perform very well. We are below like the 10% or 20%. Then more advanced techniques, and the Kaggle competition is there for that, of course, is to have innovative techniques to get more and more solved. But I think the best one reached currently 30% of the problems being solved.
Oh, interesting.
Just pretty low.
So I guess it's not trivial to, I guess, for like human programmers to solve it too. It's like
no, and the constraint is that being solved by not by solvers and not by other means than an LLM, basically. I will push a link in the chat, in the meeting chat, for who is interested to look at the RC prices and the way they work. It's very basic as a definition of a problem, and most promising approaches are talking about symbolic representations and finding a DSL and so on and so on. But yeah.
So I have a related question. Did you explore like multimodal reasoning? So basically reasoning on inputs other than text, maybe images, audio, and maybe video and stuff.
Yeah, that's a different area that I didn't cover, at least in this presentation. But kind of like the only paper that I remember that goes through that is a first graph of thoughts paper where it kind of like as in here in like cross attention. But there was like another interesting paper that a person posted on in like here, which was by friends Questiata, which kind of like did this kind of multimodal foundational model challenge with a bit of like structured generation, which I don't know if you'll be interested, but I'll just put it in chat. Yeah. But yeah, I didn't cover much of multimodal stuff because I was kind of interested in just the logic part. But I'm sure there is a lot of interesting papers there. Yeah.
Thank you.
And yeah, and sooner for me automatic. How to formalize the natural language in a formal language is already a very hard problem. Yeah, kind of like the logic LM also talked about that, I think. Some people advocate auto formalization. Interesting. I don't think it's I have like a friend who does a master's in logic who also said exactly that, but I don't know, at least for like defeasible logic, I think it's an impossibility. For like a basic deduction stuff, I think it's possible. But like, let's say for law and stuff, this is definitely an impossible thing to do, I think. Yeah. Far from being satisfactory because there's a lot of potential. Yeah. It's surprising if it's just much bigger models that suddenly. Yeah. I know like Google trained something like that was 1 trillion parameters, but they do kind of like mixture of expert stuff. So I'm not sure if that counts, but yeah, that will definitely be the dream where like somehow a bazillion parameters can solve everything. Yeah, there's no constraint for ARC except for hardware. Oh, interesting. Oh, you can use solvers for ARC. Okay, so I guess if you can make a program to do it, it'll work. Yeah,
they just like say that the search space for solvers would be like enormous and too big.
I see.
Because the problems are for each very different, and so on and so on.
Okay, yeah, that's fair. I guess nobody knows how to solve the ARC problems fast then.
There's a price on that. Like they give $500,000 out for it. So yeah, I mean, currently there is no solution, but we guess that in 2024 there will be at least a significant progress because they have also like progress prices for 2024.
Wow.
And so yeah, it's like the prime numbers problem. They are giving money now to get that thing solved. So I guess there's gonna be some evolution.
Interesting. It's still 5 months to go, right? If I remember.
Yeah, something like that. It just started.
Yeah, I remember opening Kaggle and it was like at the top. But yeah, interesting. Kind of like when you say like people try to use LLMs to restrict the search space. I remember I'm also doing a bit of research into like doing like LLMs for like hacking, like pen testing and stuff. And originally people always use like reinforcement learning and stuff, but the search space was too big, so people nowadays use LLMs because it also does restrict the search space like that. So that's a yeah, I found that interesting. But yeah, overall, like thanks everyone for coming to the presentation. But
So one more question.
oh, yeah, go ahead, go ahead.
The multimodal paper you shared, there was a channel you were showing, like show your work or something. Is that on the Argay Face server?
It's in the uh can you send me a Discord DM? Because I can share you the I can share the Discord, but it's basically this Discord called Outlines, which is basically it's a structured generation library, which basically forces the LLM to like generate in a certain format, basically.
Okay, I'll send you a
Okay,
DM. Thank you.
sounds good, sounds good. And interesting post for anyone interested after Turkey. Details are interesting. Yeah, I'll definitely check that out. Then okay, then.
Sorry, what's your Discord name? Your Discord name.
My Discord name is Chad Kensington. It's
Okay, thank you.
yeah, I think I pinged the group, so you can just actually I'm the only message in the group, so you can just DM me there. Okay, yeah. Do you have anyone have any other questions? Okay. Well, thanks for everyone for coming to the presentation, and sorry for the tech difficulties. Although I have no idea why they happened, but yeah. Hope you all have a great day, and I'll post the recording on YouTube. And for next week, I'm not sure. I was thinking of like maybe doing Triton, but I think it will depend on like whether there will be like a presenter who wants to present. Yeah. So not planned, but maybe Triton. Yeah. So yeah, that's all. But thanks for coming again. Yeah.